Hi, welcome back to the channel. So in this video, we are going to see introduction to machine learning assignment answers of week 3. First question, we'll see for two class problem using a discriminant function delta k, discriminant function for the class k where is the separating hyperplane located, right? So this is the question. For this, the correct answer is going to be, you'll see that delta 1 is equal to delta 2. Why? Here, if you separate this hyperplane between the two class 1 and class 2 boundary, if they are equally likely, this and this, those are equally likely, then we will call delta 1 is equal to delta 2. The separating hyperplane located at delta 1 is equal to delta 2. That's why the correct answer is here third one, that is delta 1 equal to delta 2. Next, for the second question, they have given here a and b, calculate the prior probability of each class, right? So from the table we know that from the table a value here, total data points are 8, class A is 5, class B is 3, right? So if we take with respect to probability with respect to A, right, you can observe here at the bottom. So probability with respect to A, the number favoring A divided by total. The number favoring A is 5, total is 8. 5 by 8 is 0.625. And with respect to B, the prior is P of B is equals to number favoring B divided by total. The number favoring B is 3 and the total is 8. So it is 3 by 8. What is 3 by 8? 0.375. Right? So that is the second answer. Similarly, we should go to the third question. So that is in class 3 classification problem. Using linear regression, output vectors they have given. So here 3 output vectors given. To which class would these points be assigned is there, right? So here this class corresponds to the highest value. The output vector is assigned to the data point. So data point with respect to the first set is 0.8, 0.3 and minus 0.1. The highest value in this is 0.8. It belongs to class 1, right? Then come to the data point of 2, 0.2, 0.6, 0.2, right? So for this highest value is 0.6 and it is class 2. Data point 3 is highest is 0.7 and it is class 3. So the class assigned to 3 data points are class 1, 2, 3, right? So for this correct answer is fourth one. Similarly, if you go for the fourth question, if you have how many classifications? 5 class classifications, and you want to avoid masking, right? 1, 2, 3, 4, 5. Avoid masking using a polynomial regression. What is the minimum degree of polynomial you should use is, so it is about k minus 1. If the k classification are there, minimum masking to avoiding is k minus 1. If it is 5 minus 1, that is 4 is the correct answer. Then fifth one, consider a logistic regression model where the predicted probability, this is a problem. So that is what you can see the fifth problem, the log likelihood. You should use the formula, this one, where they have given the predictable probability is 0.4 and actual label they have given, that is y. In this y is given, p is given, start substituting in this formula, you will end up with ln of 0.4. So in ln of 0.4 value is minus 0.9163, right? So this is what the correct answer. In the answer you will be having plus and minus, so you will end up with minus 0.9. Sixth one, what additional assumption does LDA make about the covariance matrix in comparison to basic assumption, right? So for this question, look at here, linear discriminant analysis. Assumption that covariance matrix is same for all classes, right? So that is a correct answer. Along with that, for linear discriminant analysis, it simplifies the model and leads to the linear decision boundary. It follows the Gaussian distribution. Gaussian distribution shares same covariance matrix. Along with that, you should know also this. Seventh one, what is the shape of decision boundary in LDA? So it is linear. Eighth one is a problem. So Fisher criterion, you should use the formula, that is this one. Here they have given mu1, mu2 variance with respect to 2 they have given. So just substitution. If you substitute it, you will get the answer as 4 by 5, that is 0.8, right? Then last one, ninth one. So ninth one, direction vector they have asked, right? So for this they have given you mu1 and mu2. So start using the formula for direction vector. Mu1 minus mu2, no issues. Then S inverse is there. So S inverse is nothing but S omega is identity matrix, and S omega inverse is again identity inverse, that is same exactly, right? So W is equals to this. If I put all this, you will get minus 3 divided by minus 4, right? So minus 3 by minus 4, sign doesn't affect the dimension. And look at here, you are not having the answer like minus 3 minus 4. Is it correct? No. So at that time, what you should do, you should take the normalization of this probably, so that, so you will get minus 3 minus 4 normalization. How to take square root of this minus 3 square and this minus 4 square, it is root of 25. Root of 25 is 5. So what you should do, you should divide this 5 with this. Okay, so 3 and 4. So 3 by 5, what is 3 by 5? 0.6. What is 4 by 5? 0.8. Where is this minus? Sign doesn't affect the direction, so you can treat those as plus. So the correct answer is the last one, 0.6 and 0.8. So this is the explanation with respect to the introduction to machine learning answers. Okay, so stay tuned to this channel, click on the bell icon for the latest notifications. We'll see in the upcoming videos about the next set of assignment answers. Thank you.